This question is called sum of random variables, and it says assume that x sub 1, x sub 2, etc., and x sub n are independent and identically distributed random variables with uniform distribution between 0 and 1. What is the probability that s sub n, which is the sum of these random variables, is less than or equal to 1? The first thing to notice is that n is some variable, and so as it's safe to assume that as n changes, your probability will change too. And that means we're trying to find a probability in terms of n. So we're trying to find that's what we're trying to find. This question, it'll help us to, I guess, start with n equals 1, n equals 2 to kind of see the shape, and then from there we can try to generalize the solution. This question is honestly hard to grasp. It's pretty hard, so I don't know. You can't. It's hard to get it on your the first time, I guess. You have to understand it first, and then you can repeat the pattern in the future. So for n equals 1, we're saying that the sum of n is just x sub 1, and we have to try to find a probability that x sub 1 is less than or equal to 1, but we know that x sub 1 can only be between 0 and 1, and so that probability is 100%, or 1 out of 1. Okay, for n equals 2, we want s sub n, which is equal to x sub 1 plus x sub 2. We want to find the sum being less than or equal to 1. So that means that we have the first term can be between 0 and 1, and so can the next term, right? And so we have a two-dimensional plane. Kind of like this, between 0 and 1, and 0 and 1, 0, right? Is that 4 by 4? Okay, no, here. Okay. This is x sub 1, this is x sub 2. If x sub 1 is 0, x sub 2 can be anything between 0 and 1, right? It can be all of this. If x sub 2 is equal to 0, x sub 1 can be between 0 and 1, like all of this, right? But then let's say x sub 2 is 1/2, or x sub 1 is 1/2, doesn't matter. Then x sub 2 can be between 1/2 and 0, right? Like this, kind of like this, right? And so you see it's half. It's like a triangle where half the values work, right? So the probability here is equal to 1/2. Now, for the n equals 3 case, I guess it's going to get a little hard, right? And so n equals 4, same case, right? N equals 3, you'll get a cube. N equals 4, you're going to get a hybrid cube, which is hard to even conceptualize. So it's better now to find an equation before it gets out of hand. So we're trying to find now s sub n, which is equal to x sub 1 plus x sub 2 plus x sub 3. Okay. This is going to be a bit challenging. So what we can do is we can say, let's say x sub 3 is some variable t, right? Which can be between 0 and 1. Cool. Now, since we know that x sub 3 is equal to t, we're trying to condition based on that. And so that means that x sub 1 plus x sub 2 can be at most 1 minus t, right? Because if we can be between 0 and 1 previously, and we're saying x sub 3 was some t value, then the remaining portion we're allowed to have is 1 minus t. Now, if you notice, now we're trying to find probability x sub 1 plus x sub 2 is less than or equal to 1 minus t. It's kind of like the previous part, except instead of being less than or equal to 1, it's less than or equal to 1 minus t. So we can kind of solve it similarly, and then I guess combine what we have and what we used to have. So since we're between now it's like 1 minus t is the max. We must scale our terms like how we had here between 0 and 1. We have to scale them by 1 minus t, right? Each term is being scaled now by 1 minus t. And there are n minus 1 terms, right? If we had 3 terms, we have to scale 2 of them by 1 minus t. Okay? We're going to find volume of n because previously the area was the answer, right? We're in 2 dimensions. Now the volume will be the answer. We can just say for now that we're just going to call every answer like v sub n. Like call this v sub n minus 2 or v sub 2 because just for simplicity. And volume, area, whatever will give you the answer. It would be the portion that is, you have like a total possibility space, which is like the overall volume of the cube or the square. Our target is the portion that makes this work. And so like v sub 2, v sub 3 is like the kind of portion we're trying to solve. V sub n is equal to, well, first let's kind of see what's happening. We're saying it's kind of like the previous answer, right? V sub n minus 1, right, we had here. But we said every term was scaled by a factor of 1 minus t. So that, but every term being scaled by a factor of 1 minus t, and there were n minus 1 possible terms, right? There's 2 terms here being scaled by a factor of 1 minus t. Now t can take the shape of any number between 0 and 1. Now we pick t arbitrary, like t is arbitrary, not like a variable that can be between 0 and 1. And so we must add up. So if t equals like 0.3, we have some probability. T equals 0.2, we have some probability. So we have to add up across all possible t's. So we must integrate from t being between 0 and 1. And now you're saying, okay, v sub n minus 1 was a 2-dimensional thing, right? V sub n is 3-dimensional. If we multiply a 2-dimensional by some scaling factor, we're going to stay in the 2nd dimension. But we can't forget the classic dt, which gets us that 3rd dimension. Okay? We can take out v sub n minus 1 because it's a constant. 1 minus t minus 1 dt. And I'm just going to skip the integration step because it doesn't really matter. But that equals this portion is equal to, this portion is equal to 1 over n. Okay? So v sub n times 1 over n. Or v sub n minus 1 here. Okay. We said previous, so we're saying n equals 3, right? Then, and v sub n minus 1, in this case, we said was 1/2. So that means that v sub n is equal to 1/2 times 1/3. And then the next one, so that's equal to 1/6, right? That's the answer for that part. N equals 4, we said it's going to be v sub n minus 1 over n, right? V sub n minus 1 in this case was 1/6 times 1/4. So if you notice, we are getting a factorial type thing, right? N equals 1 was 1 over 1. N equals 2. Well, n equals 1, we had 1 over 1. N equals 2, we had 1 over 2. N equals 3, we had 1/2 times 1/3, which is equal to 1/6. N equals 4, we had 1/3 times 1/4, which is, 1/6 times 1/4, it's 1 over 24, and so on. We're going to get some sort of factorial thing where each term is previously a factorial type and then times 1 over the next number, integer. So probability in terms of n is 1 over n factorial. And that is the answer. It's a little bit complicated, but yeah, that's the answer. 1 over n factorial. Why isn't it showing? There it is. Okay. And yeah, that's all.